Hi everyone, welcome to Advanced SQL class. I'm going to be running this class today for you. I'm Slav, I'm Data Engineering Manager at Facebook. Really excited to be here. Thank you very much for joining, and thank you very much for all the organizers. I think summer school is a great initiative and I'm proud of being a part of it. As the title suggests, today we're going to talk about SQL. The title says it's Advanced SQL, so we will go a little bit more beyond the basics. I'm actually going to skip very, very basic stuff, and I will jump straight into a little bit more advanced stuff. But before I do this, before I actually jump into the coding, a couple of thoughts. So throughout my career in the bigger companies, the smaller companies, and in different roles, data-related roles, but I've been software engineer, data engineer, also researcher at academia. One of the skills which let me thrive and succeed was SQL. And I really believe this is a crucial skill to have in data-related roles. And it's called language of the data from a reason. Right, it lets you to interact with database with the bigger and smaller data. It lets you write queries which answers complex and sometimes simple, sometimes complex questions, do all the analysis. So thank you very much for having interest in learning more of the SQL. And with that in mind, let's actually jump straight into the coding. Again, a couple of logistics. I'm going to be using CoderPad as a tool. It doesn't really matter. It's just a tool for me. I wanted to have something which looks nice and with pet example of database, so I can run SQL and interactively show you what I'm coding and what are the results from the small database. So that's one thing. The other thing is the dialect of the SQL. So as you probably know, SQL has many dialects. Each database may have their own implementation of SQL. I'm going to be using PostgreSQL, but if you don't know PostgreSQL, don't panic. If you use MySQL, T-SQL, or any other type of SQL, you should be fine. And the reason for this is most of the language is the same across all those dialects. And most of the things I'm using today will be exactly the same across all those dialects. So PostgreSQL, but it doesn't really matter. You can apply all the skills you learned today for any sort of SQL. Another thing is the database. As I said, it's just a pet example of database. We will be using 4 of those tables. So think about imaginary company which has a bunch of employees. Each employee, works in some department, right? I don't know, marketing, engineering, whatever. And each of those employees can run one or many projects, right? They run projects, and the project have some details like title, start date of the project, end date, budget, whatever, right? So this is our setup. We have our database, and let's start in. As I said, it's gonna be a little bit more advanced, but don't panic. It's not gonna be rocket science. What you need to know to successfully go through this class is definitely you need to know what SQL is, what database is, what the table or schema is. So all those basic concepts would be perfect if you know primary keys, foreign keys, but you're going to be fine with all that as well. And you need to know how to write, select a bunch of columns from, choose the table and where. And it would be great if you know group by as well, right? Aggregation function and group by. So if you have this, and this is pretty much basic, you should be fine to follow this class. In case you don't know this, feel free to stay at the class. You will definitely learn something more, and then you can catch up and then rewind and catch up. Cool. Let's actually start doing some coding. I'm gonna be doing the coding live, so we may have some errors, we may have some mistakes from my side, and we will see some bugs probably. I will be explaining those bugs and fix them as we go as well. So it's gonna be more like a little bit more realistic scenario where instead of slides or copy pasting stuff, I will try to do the live coding, right? So let's jump in to the first thing, which is let's just select all the employees from the employee table, right? And let's just do this for now, right? I hit the run button on the right hand side. You can see the results. Let me actually smaller. And we can see just 6 employees. As I said, it's just an example database. We have stuff like first name, last name, salary, department ID. That's great. So let's do some filtering. I said we should know where. As you know, you can use where to do filtering. So let's say that we do 10,000K. Let's say we just want to select the employees which earn more than 10,000K, right? I can use where clause and I can just pick a column and say the condition on filtering. I can run it and we have just 5 rows now, right? We had 6 before. There's one person which earns exactly 10,000. I've used greater than, not greater than, equal to. So this row doesn't meet condition. So we filtered, so we filtered out this row, right? So pretty basic, that's fine. Let's extend on this, right? So you can write inequalities, right? Bigger than, smaller than. You can then do bigger than, equal to, not equal to, etc., on all sorts of numbers. That's great. But what you can also do, you can use the conditions on the strings as well, right? So there are different data types, right? There are numbers like integers, for example, and there are also strings, or how we call them, varchars. And you can operate on them as well. Like, so let's, for example, choose all the rows on our database which has the name John, right? So all the employees which are named John. And so you can use just equal sign and you can hard code string, and that will filter out to all people who are named John. That's great. It's fun, but still a little bit limiting, right? You need to hard code exact string. If you made a typo, like if you do Joe because you forgot to add n at the end, you run it, it will look for first name which is exactly John, right? So we haven't found anything, right? So it's a bit limiting, and it also doesn't allow you to answer more sophisticated questions, like, for example, hey, give me all the employees which starts with A, right? The first name starts with A, or last names which start with ends with N, whatever. Something which does not require you hard coding things, right? Because in reality, in the real world, where you go there and you run a query, there is no way that you're gonna always have the exact string you need to find out. Sometimes you need to have a little bit of flexibility. And to do this, you can use like clause, right? Very powerful thing when you work with the strings. The way it works is, you just do the column name and you type like, and at this point, the first name, like John, will give you exactly the same result as first name is equal to John. Those two are the same things. No, they're written differently, but they will give you exactly the same result. They will give you all rows where first name is like John. Where it gets more powerful, it's that like allows you to use something called wildcards. So what are those wildcards? We have 2 very popular wildcards. One is percentage sign and one is underscore. So percentage sign pretty much means 0 or many characters, right? And those might be any characters. So anytime where you're gonna write after like in the parentheses percentage, database will interpret it as you want 0 or more. Any characters, and the underscore is exactly 1 character, and again it's any character. So let's use it. Let's use both of them and show you in practice what it means. So let's say that I want to find all the first names which starts with A, right? I can type capital A because I want my first names to start with capital A, and then I want to have 0 or many characters, right? I want all first names which just starts with A. So Anne, Anna, whatever name starts with A, right? I can add this percentage sign, and then you can see that actually we have 1 first name that starts with A. It's Ava. And I didn't have to know exactly that this is Ava, right? I was looking for everything which starts with A, right? Now, the percentage sign can be anywhere, right? It doesn't need to be at the end of the string. It may be at the beginning, in the middle, wherever you want. So let's use another example. Let's find all the last names which ends with n. So if I run it, we'll have actually 4 rows, and you can see that all the last names, their last letter is n, right? Which is exactly what I expressed here. Give me all last names where, you know, at the beginning we have 0 or more characters, and then at the really end the last letter is n. So that was the percentage sign. Now let's use the underscore, right? Let's get back actually to the first name, and let's try to get let's try to get any name, any first name which has just 3 characters. How are you gonna do this? We're gonna use 3 underscores. Why? Yeah, because, you know, one single underscore is 1 character. So if I use 3 consecutive underscores, it means I'm looking for any string that has exactly 3 letters. So let's see if we have any names. And we don't have any names. Oh, because instead of like, I've used equal to. So we just had a bug from my side. I forgot to change equal to like, and now, you know, underscores just act as a normal underscore, right? It's not like clause, so it's not interpreted as a wildcard, right? So I need to change it to like, and now I should have 2 rows. Now I have 2 rows, no surprise anymore. 2 rows, I changed equal to like, and now after change, the underscore is now interpreted differently. It's not the underscore anymore, it's exactly 1 character, right? And we have 2 names, one called Ava, one is Ava, one is Ian. Amazing. What's more, we can join those 2 together, right? You don't need to use one or the other. You can actually join, you know, use both of them. Let's try to do it. Let's get the last name, which starts with N, and I don't know, ends with N. Let's see what we get. Let's actually remove N. I want Muffinson and I want Mills, right? So I said, give me last name. First letter needs to be capital M, and then 0 or more characters. We get 2 results. And then let's say I want the last name to be at least 6 letters. It may be 8, it may be 10, it may be 100, it may be 6, but no, not shorter than 6. How we can achieve this? Let's combine the percentage sign with the underscore, right? So if we want to have at least 6 letters, that's the first letter, M. That's going to be second letter, third letter, fourth, fifth, and sixth. Till this point, we are saying first letter needs to be M, then we have 5 characters. And then this percentage sign means, you know, 0 or more characters, which pretty much means we will get only the last names which are at least 6 characters. Let's run it. We have just Muffinson because Mills is 5 characters, right? If we remove 1 underscore, and now we are saying give us at least 5 characters, 1, 2, 3, 4, 5. See, this is at least 5 characters. We should have the Mills back. Yeah, and we have them back. Amazing. So this is a like clause and the wildcards. You can mix them together. You can get really powerful results by using those, which is amazing. Next thing, let me show you another thing. So let's just take 3 columns. Let's take first name, let's take last name, and let's take just a salary, right? And let's keep the where just to keep it more interesting. Let's remove comments. We have 3 columns selected on the right hand side. You can see results, right? And let's say that instead of these 2 columns, first name and last name, I want to have full name, right? And by full name, I mean, you know, full name will be in our example, first name plus last name, right? We skip if anyone has a middle name, right? How can I get the full name? Well, I can go to employees table and look through it, but there's no full name column. We have just first name and last name. So what we need to do, we need to create a new column. And this column, you know, will go through some sort of transformation. It will use one or many columns to transform and will arrive with a new column, which is a full name. So now how can we do it? We can do it by using single row functions. Now, there's many single row functions. Many databases have their own functions. So whenever you're using this kind of functions, I would advise you to go to the documentation and check what's available. But the way you use them is pretty much similar, is the same across the board. So let's use one of them. Let me give you an example. The function works like this. There is like a function name. There is a parenthesis. And there are arguments. There's argument 1. There may be more arguments up to argument n, right? And some of them might be mandatory. Some of them may be optional. You need to go, whenever you're using any function, right? You probably want to go to documentation and check how many arguments you should use and what are the optional argument, what are mandatory argument. But you basically use the function name, you add the parentheses, and within parentheses, you have comma separated arguments or single argument or no arguments at all sometimes. So the function I'm going to be using today is called concat. And concat is concatenating strings, so stitching them together, right? So let me show you how to use it. I said function name, we have it, parentheses, we have it, and arguments in between. I know, because I know PostgreSQL, that concat takes one or many arguments and then stitch all the arguments together, where the argument is a column, right? So let's show you this step by step. Let's say that I will use first one argument. So now my function takes one argument. Let's name new column as a full name. So what we are doing right now, I'm saying, okay, let's create a new column. It's going to be called full name, right, as full name. So we're going to name our function full name. And it will be a result of the function concat, where I've passed just one argument called first name. Now, I told you that the concat concatenated the arguments, right? So because I just added first name there, I'm expecting to see that full name will be actually exactly the same as the first name. Right? Because, there's nothing to concatenate. I just added one argument. Let's run it. And I have back. Where is the back? Syntax error near. Okay, so I forgot comma. Right? I've created new function. It's over here, but I haven't ended it with the comma. There's no comma here. By the way, just a quick thing. You can add comma at the end, and you can add the comma at the beginning. Doesn't really matter. Different people prefer different things. I've seen people using commas at the end. I'm one of those annoying people who use it at the beginning. I think it's just more useful at the beginning, but it doesn't matter, right? Okay, fix the bug, added comma, we run it. And as I said, first name is exactly the same as full name, right? So we use a function, but it's not so useful yet. So let's actually add the second argument, which will be last name, right? We said full name is first name and last name. So I added second argument. As I said before, it's comma separated. So comma and the other argument. Let's run it. And we have a small surprise, right? It's concatenated, it's great, but it's a little bit not readable, right? Because there is no space in between, right? What can we do with this? Again, let's just pass an argument, right? Concat takes column names or just hard-coded strings. So what I can do, I can say, let's add space in between. So it will take first name, concatenate with the empty space, and concatenate with the last name. Yeah, from left to right. Let's run it. And now we have full name and the previous columns, right? So much better now. We can get rid of those because we don't need them anymore. We can run it. Full name and salary, amazing. We just created a new column. And let's use another function just for the sake of example. Let's use a length function. So length function is it gives you the length of the column, right? If it's a string, it will tell you how many characters string has, right? How we use it? Again, function name. So I know that the function name, I don't need to check documentation, then parentheses as always, and then arguments in between. Length take one argument and a column, it will output you the column name. So let's check the first name length and name it as a first name length. Right? Let's run it. And we can see 3 and 4. That makes sense because Ava has 3 letters, John has 4 letters, right? Which is great, but you can do even better. You can actually use many functions as within the other functions. So you can use function as an argument of the other functions. So it kind of sounds like a bit of inception, but when you think about this, let's get us length of full name. Full name length. How to do this? Length take one argument, as I said. This is the column name, but we can actually copy this over, right? And put this as an argument, right? And what we are saying is, hey, my length function use this single argument I've passed, which is a result of another function, which in this case takes 3 arguments, but it doesn't really matter because under the hood, SQL will first resolve this, right? And it's gonna be single argument, and it will be passed to this second function. Let's try to run it. 13 characters, 10 characters, makes sense. Yeah, 3 characters here, 1 character for space, and the rest of the signs. You can count it, see if SQL is not lying. It should be exactly the same, right? And you can do even more, right? In the sense like there's no limit of how many functions can use how many functions in between, right? Let's play with the full name a little bit more. Let's take a full name and length, where I want something like this. I want a column which has first name, last name, and then it has parentheses, and within parentheses it has the length of the everything, right? I want to create a column like this. How to do this? Okay, so we need concat for sure, right? We want to concatenate strings. I said I want first name, space, last names. We have it. Let's break it down a little bit to better readability, right? So you can do something like this. I've just added a new lines so that instead of having everything in one line, I'm breaking it down. And SQL will treat everything within parentheses as a one the same thing, right? So it doesn't matter for SQL if it's one physical one row, one line, or you break it to many lines, right? You can do for each argument, you can use a new line, right? So you can see it better, right? If you have long queries, if you do more complex analysis, you use many functions, you may want to break it down because then you read it or someone else read it and you want to understand what's written, right? As a human beings, we sometimes can, see better if things are not, clustered together. Okay, so we have first name, we have space, we have last name. Then I said we want to have parentheses, right? So let's add start of the parentheses, space and parentheses. Then we want the length, right? So I can use our length function. I can just literally copy paste this. And you can see that this argument is a funny one, right? Because there's an argument within the concat function, which will use a length of another concat functions, right? So a bit of inception here. And then we need the last one to close the parentheses, right? Let's close the parentheses and let's run it and see if I didn't make a mistake. No, we have Ava, Martinson, space, 13 characters. So this thing has 13 characters. And this is the same, the number in parentheses is the same. So we did well, right? So those are functions. There's many functions. You need to go to the documentation, check, but they will help you to create a new, new columns, to do some math expressions, to do some string operations. Like some other function which I think of is, I don't know, function which capitalize string, or lowercase whole strings, or uppercase whole strings. Bunch of different functions. useful in a bunch of different scenarios, right? So usually, you know, when you want to do something, like let's say you want to concatenate string, you're figuring out how can I do it? You know that this is the column level operation, so you can go check what functions are available within your SQL language. Cool. Let's go deeper. Let's actually answer some questions. So let's remove the where here so to have more rows, so it's more interesting. And we can remove this length. Let's actually keep the full name instead of this weird thing which I created. Let's just keep it simple. First name, space, last name. That's our column. And we have salary. And let's say you work for HR. And the question is, how many people earn salary within certain ranges? And let me just paste the ranges prepared before. Let's say you want to know how many people earn between 0 and 20K, no, 20,000 pounds inclusive, right? The angle bracket here means it's inclusive. How many people earn within the extended range? So how many people earn more than 20K up to 50K inclusive and more than 50K, right? So we can use SQL for this. We can query our employees database, employees tables, and just get the number, right? How you can do it? Let's do it step by step. Let's take the first approach, which is just a naive approach, and let's just write a bunch of queries. Like the first one, we can use where clause, right? I want just the rows where salary is. Salary is between 0 and 20K, 1, 2, 3, right? If you don't know between is doing exactly what it sounds like. It's saying, hey, the value has to be between this number and that number, right? Let's run it then. And we have 3 people. We have John Smith, Ava, Mike, all of them, and between 0 and 20. So good for us. Let's go deeper. Let's copy and paste this. Sorry. Here we want extended band now, right? So pretty simple. Let's do the same thing. 21 to 3. So we have 20,000 and then 50,000, right? Let's run it and see what we get. Let me just clear the output because there's gonna be something strange, which we will have surprise. Okay, so the surprise is now, you know, I expected to see, you know, people within 0 and 20 here and more than 20 up to 50 here, but suddenly I have, you know, John Smith, who's earning 20K, and Mike, they are also earning 20K. Why is that? Well, this is because the between is inclusive. So when you're using between, you need to watch out for those edge values, for the highest and lowest value within the range you define. And between will actually include those numbers. So what you're actually saying within this query, it's not everything bigger than 20 up to 50 inclusive, but you're saying everything equal to or bigger than 20 up to everything equal to smaller than 50. So this is not quite what we want. Yeah. What can we do with this? We have a bunch of options. First of the option is make the 20,000 number within between slightly larger, right? We know that this is salary. We know that if someone is earning more than 20,000, it's at least 20,001 pence or 1 cent, whatever currency you're working on, right? This will make sense, right? You cannot earn, you know, 20,000 and 0.5 cent. So this will work. If we do this, this number is slightly bigger than 20,000, so we will get rid of John and Mike. Let's check it out. And as I expected, there is no John and Mike over here. Yeah. The other thing we can do. So this is quite it works in some context, but sometimes Now, sometimes it's hard for you to do this slightly bigger number, right? Let's say you work on some real numbers and you care about, I don't know, multiple decimal places, right? It may get tricky. So what you can do is use, express between a little bit different. So what you can do is you can say, hey, give me all the rows with salary bigger than 20,000, right? And salary smaller than or equal to 50,000. You keep the parentheses just to logically separate the conditions. And what you're saying here, you're saying, okay, where filter me all the rows which satisfies those two conditions. The first one in the parentheses, which in our case is salary is bigger than 20,000. And another condition which has to be satisfied is salary has to be equal or smaller than 50,000, right? So you can stack many conditions together. Each condition will be in parentheses, and then use some logical operators like and, on, or whatever from math, right? There are and, or a bunch of more if needed, to use multiple conditions in the where clause, right? So now it should give me exactly the same result. It should give me the Colin and John. There is no the wrong rows here. So that was it. And the last query, we just need, this is going to be a simple one. We want the high band. Remember, we are still in those bands. We want salary be bigger than 50,000, right? And not inclusive. Bigger than 50,000. Let's get rid of the parentheses. So everything is clear. We run it, and great. We have our answers. We know that in the basic band, we have 3 people, in extended band, we have 2 people, and in the high band, we have 1 person. Now, although it gave us a result, to be super honest, it's not very practical. This is a very simple question, and we wrote 3 queries, and we require a human being to interpret the results, right? I need to know that this is the result of the first query, and that the first query is about the basic band. You need to know that the second refers to this one, and that refers to this one, and so on and so forth. So it's a great result, but you're not going to share this kind of results with other people, but because they don't know what you're doing. So what I want for us to get is to get to the point where we have just 2 columns, band name and the number of people. Right? The way we're gonna do it, we're gonna use something which is called case. Super powerful concept. First, I'm gonna show you syntax. So syntax for case looks like this. You start with case, and then you end it with the end. And case will output you new column. So that's gonna be your new column. If you are familiar with any programming language, you for sure know something like if-else. If something, then something happens. Else, something else happens, right? This is pretty much what case is expressing. So we have this case, and between the case and end, we have a bunch of conditions. And we're saying, hey, when condition, in our case here, this is just a syntax. So we have something called condition 1. Right, whatever the condition is. But if this condition is true, your new column will take value number 1. If this condition is false, the case will evaluate the second condition. And the second condition is, again, it's something different, right? It's a different condition. It may be true or false. If this is true, your new column will take up this value number 2, and so on and so forth. Now, you can have 1 when, you can have 100 whens. It doesn't really, it's up to you. There's no limits here, right? But then we have this optional else at the end. And so what this else is? So else is kind of like the ultimate fallback for you. So when you're doing the case, you check condition by condition from the top to bottom, but at some point you may run out of whens, right? When this, when that, and then suddenly, none of those whens is true. Then you may use else, which is saying, hey, if none of the above conditions are true, just use this value, right? So in our case, if we would have just 3 conditions, 1 to 3, and none of them is true, the new column will take value n, right? Because it will fall back to n, to else, right? So let's try to use this case construct to create the band name, right? The salary band name. How to do it? Let's comment out those for a second. Let's say take one of them. Let's say this again, and let's keep full name for now. Let's keep salary for now, and let's add this new column. So I'm gonna take this case statement, and I'm gonna modify it a little bit so it works. So first condition. What's gonna be our first conditions? So we want our new column to be called salary band. And our salary band will take 3 values. It will be either basic or extended or high, right? If our column salary band is basic, that's the condition it needs to be satisfied, right? So condition number 1 will be this condition over here. We have it already because we wrote those 3 queries before, so we can just copy paste, right? Remember, this was the query for the first band. I can take this, copy, and replace it with this condition, right? So we are saying, okay, when this condition, then what? Then we said we want the column to be basic, right? So let's add a real value. We're saying when this happens, then the column will be basic. What was the second condition, right? The second end, well, we can just copy paste it, right? Let's take the second condition, and then the value gonna be extended, right? Extended. Good. And the third one, again, let's just copy paste because we did the hard work already. And copy paste it, and it's gonna be high, right? High. So we have 3 bands, 3 conditions for them. Now let's think if we need this else. So sometimes you need it, sometimes you don't need it. In our case, to be honest, we don't need else because we have 3 bands, we have 3 conditions. There's no way there's gonna be something else. Like you cannot have the salary with the negative number. I hope so. I hope you're not working and paying your company. And anything bigger than 50K will be high, right? So we don't need else. So let's get rid of else. Now we have really clean case statement. Again, case statement starts with case, ends with and, between it has conditions. So let's run it. Let's remove this where, right? Just not to interfere. And amazing, we have our new column. It's called salary band, and you can verify me every time the values are between 0 and 20K, the column will be basic. Anytime it's between 20 to 50, it's going to be extended, and it's going to be high when it needs to be high. When it's where it's more than 50K, right? So cool. This is the case statement, and let's extend it even more. Let's say we are in this HR, and we now still I need to count the people, right? I said I want salary band and the number of employees, right? How can we do this? So if you remember, there's group by clause, which groups by, and you can use group by with the aggregations functions to give you some numbers, right? If you don't know group by, don't worry about this, super simple concept. And I'm gonna show you right now. So what's gonna be the grouping we want to use? I said I want the number of employees by the salary band. So we want to group by salary band. Group by, and we want to group by salary band, right? So you can do this. We can get rid of those. So we have now just 2 columns. No, 1 column. One is salary band, and the second column is what we look for, which is the number of the people. How can we do it? So And every time you use group by, you use it along with aggregations functions. What are those aggregations functions? For example, min, right? This would mean give me minimum value within each groups, right? So it would, so if I use min salary, this query will mean give me minimum salary across salary bands. We can run it, we can check it. So minimum salary in high it's 80, in basic it's 10, right? Makes sense if you check the data. That's how it's gonna be. If you look at the all basic rows which has basic salary band, the smallest number is 10. So it's 10 as well here. If you look at the extended, the smaller number is 30. So it's 30 here. And high had just one number, so it's 80, right? So this is the mean aggregation function. You can change it to max, you will have the highest number. You can change it to average, why not? This will give you average salary within the band. You can change it to what? Sum, why not? Maybe you want to sum all the salaries within the bands, right? We want the number of employees. So how can we get the number of employees? So there is another aggregation function called count, and this counts the number of rows within the group, right? Which is exactly what we need, right? If you think about this, that was the results, right? If you are a human being, you would just count the number of rows, which has the basic value. So that's what we want to do. So you can count the salary band. So count, usually when people use count, they use count star, or they could use count one. Sometimes they use count and the column name, but to be honest, most of the times you can just use count star, right? There is no difference between those, pretty much between those three things. So you can count column name, you can count one, you can count star. All of those will give you the same value. So number of employees. Let's run it. That's our result. So we know that in high band there is just one employee, in basic there's 3 employees, and extended 2 employees. Let's verify this. High 1, it's just 1. Basic 3, it's 3. Extended 2, it's 2. It works. Just for the sake of showing you that you can use the count one as well. You can find it when you work with SQL. You can sometimes find that it's this kind of usage, and you may use salary band. It's not. Let's see if it works actually. Now, so now it's saying that the salary band doesn't exist. So why it happens, right? I said you can use column name, right? That's true, but actually not all the SQL dialects will recognize aliases. What is alias? Alias is just this column name I said, right? So every time you use as, you're using alias, and you're just creating the alias so that you can refer a column. But in the table itself, like here, the salary band doesn't exist. And that's what this error is saying. It's just saying, hey, sorry, salary band doesn't exist, right? So if you really want to use the column name here, you would actually have to copy paste all of this thing and use it like this, right? Now it should work. It works. It gives you the same result. There is no error anymore. To be honest, it looks ugly, right? Why to do this when you can just use, count one, right? Or count star. That's it. We have number of employees within the salary band. We have the grouping. Just for the sake of making sure that it's covered, you can group by many columns, right? So here I'm saying, okay, give me the number of employees by salary band, but I as well can say by salary band and department ID. How I can do it? You need to just group by more columns. So here I'm saying group by. I'm grouping by 2 groups. Need to add it here as well. The matrix stays the same, and we have more results, right? So each row will be unique combination of salary band and department ID. I don't want to dive into too much into theory, but there is some nomenclature which is useful to know, and those are dimensions and metrics. Many times when you work in data-related industries, you can hear dimensions or metrics. The simplest way to explain this at high level is the dimensions. Those are the attributes which you group by, kind of, right? And the metrics are the numerical values, the quantitative values, which you want to measure, right? So in this case, I was measuring the number of employees. So number of employees was my metric by salary band. Salary band was dimension here. In this case, I had two dimensions, salary band and department ID. And the metric is number of employees, right? So pretty straightforward concept. But when you think about bigger companies, and when you think about real world examples, let's say you have multiple products, you are a big company, and you have a product, multiple products, right? And you are international company, so you have multiple countries. You may want to know things like, hey, how much revenue we make by country and by product, right? So that you want to do the multi-dimensional analysis, and you want to know, for example, hey, this country, this product is very popular, in the other country, maybe some other product is popular, right? So the country and the products will be dimensions in this scenario, and the revenue would be a metric, right? It doesn't impact your SQL. It's just a naming conventions. It's not what people use. It has some other consequences in fields like data modeling, etc. You don't need to know from the SQL, but it's a data-related event. You will definitely, while being in the data world, you will hear things like dimensions, metrics. So that's what it is at high level. Okay, so last thing for today. Let's so far we've looked at the single tables, right? Let me do a small cleanup, and we were using like just employees, right? It's rarely the case in the real world that you're gonna use one table, right? There's no site database out there which is working fine and which is actually being used with single table. It's not practical, it's not possible. Usually what people do, and they design database, they have multiple tables, and they try to group somehow those tables logically. So it's easier to use, it's easier to store, etc. So you will have multiple tables. Each of the table will be about some sort of entity. Just like here, right? We have the employee, and it's the table that stores employees, and it has all attributes relevant to those entities, right? Or all dimensions and metrics relevant to each employee, right? And then you have separate table for departments, separate table for projects, and then when you ask a simple questions, let's instead salary band. Like here we have the salary band, right? Let's change our question. Let's say HR is not saying salary band, but HR is saying department, right? By department name, right? They want to know exactly, hey, engineering, there is 10 people in engineering, 5 people in marketing, or whatever, right? You're not gonna answer it with just employees, right? We have department ID. Yes, okay, I can do this. I can do department ID, select department ID. I don't need this salary band anymore, right? I need to group by department ID. Oh, by the way, another cool trick is when you group by, you don't need to specify column. You can also say 1 or 2 or 3, where 1, 2, and 3 signifies which columns from the select you want to group by on, right? So if I do group by 1, it will group by this column. So group by 1 or group by department ID, in my scenario, is exactly the same. It's a good format. I actually prefer using 1, 2, 3, the order-based columns, because it's just cleaner for me, right? So if I do this, I have department, I have the number of employees by department, but I don't know what department ID is, right? What's engineering? Where is marketing? If you give this to your HR people, they will tell you, hey, I don't understand. That will be fair from their side. So even this simple question in this pet example database, we need to use two tables, right? So we need to learn how to stitch tables together. Otherwise, we're going to be very, very limited to just the scope of one table, which not going to be necessary, not going to be exhaustive. How we can do this? Well, let's think how you would do this if you are a human being. And I hope you are, by the way. So let's do this. Let's do select start from employees. And let's do start. I don't need department ID and departments. Let's clean up the output. So I just want to clean output. And let's run those two queries, right? So first name, last name, salary, department ID, and department. So if I want to know for which department each employee belongs to, as a human being, I would go to this row. I would check, okay, there's department ID. It has the number one. I have also department table. And it looks like from this graph that department ID is actually the same thing as the ID in the department table, which makes sense. Department ID sounds like it's the case that it's the ID from the department table, and the entity relationship diagram shows me that actually this is the case. So I would use this second table as a lookup, and I will see that department ID 1, I will look for 1 over here, and I would say, okay, great, I know, it's reporting. Then I would go to the second row, I would see department ID number 5, great, what 5 means, I can see my translation here, 5 is Silly Walks. Amazing, this Ava is from Silly Walks. 2, there are three people in department number 2. What is it? Okay, that's engineering. 3, it's marketing. Easy peasy, right? So that's how I would do as a human being. And that's what we need to do to tell SQL to do for us, right? SQL gonna do exactly the same thing. We need to tell, hey, I want to take the employee table, and I want to also use departments table. So I'm gonna join those two together. And to join those tables together, I'm gonna use department ID column as a mapping between some tables or as a join key, right? If you are familiar with the concept of primary key and foreign key, that's what the department ID is primary key. No, it's a foreign key actually. It's a foreign key here, and the ID here is a primary key from departments. But the primary keys, foreign keys, that doesn't really matter to you. What matters is that you need to have a column which is shared across those two tables, and then which you can use to join the tables together. Now, how you do the join? Surprise, surprise, you use join. So you literally write join, right? The quick heads up, there are many types of joins. There are many types of joins, but I'm gonna just use the standard join, which is under the inner join. There are also left joins, right joins, outer joins, etc., etc. We're not gonna cover those, but they are all about the same thing, which is joining tables. Okay, so select star from employees, join on departments. Right, I want to join departments, and then I'm saying on, and this on signifies on which columns you want to join the tables. And as I walk you through, it was department ID in employees, and it was ID in departments. So what you can do is say, okay, take the employees table and access department ID column. And it has to be the same as ID from departments and ID. So column name dot table name dot column name, right? Now, what I'm actually getting now is I can access all the columns within employees and all the columns within department, right? If I did it correctly. So let's do this. Let's take the first name. Let's take the last name, and let's take the department name, right? I said we did the join. I can access all the columns. Let's use name. let's add the alias so that we know what name it is, and it's the department name. Let's run it. And cool, as you can see, first name, last name is from employees, and the department name, which is actually the name, comes from departments. So I successfully joined the table. If you watch the video later on and pause it and you can check all the IDs here manually, you will get exactly the same result. Great. Couple of things here. So we can improve it a little bit. And there are also a couple of caveats. So first thing is I said you have access to all columns in this table and in this table. But what happens if the name is the same? Right? For example, ID. There's ID over here and there's ID over here. Right? So what will happen if I do this? And I can tell you it's gonna be error. What type of error? It's saying, hey, column reference ID, right? So this, I'm referencing a column. So this thing is ambiguous. So what SQL is telling me is like, hey, dude, I don't know what you want. There are two IDs. Which one I should use? I don't know if it's employees and if it's employee ID, or I don't know if it's department's ID, which is department ID, right? So you need to be explicit in case there is overlap between the columns. How you can do this? Well, you can just do that table name dot column name, right? As simple as this, it's gonna solve it, right? Now and we can add another alias, so it's more readable for us, right? So now we know this employee. This is employee ID. The other thing which I would improve here in this query is use aliases as well for tables. Now, copying pasting these employees and departments all over the places, it's a bit annoying, right? So the same way as you're using as and column alias, you can use as and table alias. And you can be even lazier than this. You can actually remove even as, and you can do just space and E, where E is alias. It can be any string. It can be this, it can be that. Whatever you want. I'm using E just because E is the first name of the table. I'm lazy, I use E, right? And I'm gonna be lazy here in departments. I will just use D. So now, after doing this, space and the alias or as and alias, anytime I'm referencing table.column, I can use those aliases. So I can now do this, E, and D over here, and I should be safe. Let's run it. Yep, exactly the same result. That's what we wanted. Great. Another tip is, we work on relatively simple queries, right? There's not much code here, but the tables sometimes are big. The query gets more complex. Sometimes it may be good to actually do the reference for the table in each column. So even the first name is unique between those two tables. You may want to do E here as well, and D here, just for the sake of your readability or future user readability, right? So now when I look at your select, I can see, okay, is E dot first name, okay, is employees, okay, so I know those columns are from employees, right? It may not seem so necessary here in this toy example, but if you think when the query has hundreds of lines of code and when your tables have, tens of columns, and when you join together multiple tables, because yes, you can join multiple tables, it actually starts to be tricky. It may be better for you to use the table name dot column name everywhere. Right. Other useful thing for you, let's list out all the columns from employees and all the columns from departments. How I can do it? Well, I can do E, I'm accessing employees, in star. And then I want all columns from departments, D dot star. Let's run it. Great. We have all the results. We have ID, first name, last name, department ID. matches here, and 2 columns from departments. You can see here, this is the same column name. You would have clash of the names, but because I did the table name dot, there is no clash anymore. What else can we do? Let's actually use join another table. As I said, you can join multiple tables. So let's just join employees projects just for the sake of proving you that that's the case. We do it exactly the same way. Join table name we want to join on is on. Now I need to have the column. Now I want to join employees, right? So hey, what is the common column between employees and employees projects? You can see this diagram that this is actually the ID from employees. So it's a primary key from employees and this foreign key from employees, right? So you can see, I don't have the alias. Let me add the alias, added ep dot. And let's just show you that I just joined those tables. And great. Now, I've joined 3 tables here. I mean, I have 1 table joined with 2 other tables, 3 tables are together. Now I can write my SQL queries, against all the columns, right? Now, if you are super careful, you will realize that there's one thing which happened. And, when I had just department joined, you had 6 rows. And after I joined the employees project, I have 5 rows, right? So, hey, what happened? There's 1 row missing, and this is John Mills. So why John Mills is missing? Sorry, this is John Mills. Why John Mills is missing? It's because John Mills pretty much does not have any project. So within the employee projects tables, there is no row with employee ID number 6. That's why there's no row here. So it got filtered out. And this is a special thing when it comes to joins. When you use just join, you are using the inner join. And the inner join, under the hood, it looks only to exact matches in the tables, right? So I mentioned at the really beginning that there are left joins, right joins, full outer joins, and all the other types of joins. And all those, the other types of joins are exactly to solve this problem, right? Because sometimes you don't want this to be filtered out. Sometimes you want to use all the 3 tables, but you don't want to lose rows, right? Then you need to know which type of join you use. Maybe you want to use left join here, right? So you want to do something like this. And this is extra thing. See, now we have 6 rows. I'm not gonna dive now into those left joins and the right joins because that's all the other stuff. There's more discussion here. That's something extra. If you practice and if you master all the materials so far, the next thing definitely would be the other types of joins. Now, as a last thing, let's just do one more thing. I've said that I want the number of people within each department. So as we already joined the employees and we joined the department, let's just, as a recap, do a quick query to get the number of rows in the department. Let's use all the things, right? So as I said, by department, so our dimension is gonna be the department name. I said I want number of employees, super easy. How you would do it as a human being? Well, you would count all the rows, right? And that's what we're gonna do as well. You count 1 as number of employees. And this stays the same, and then you need group by. Group by is at the end. And group by is at the end. You want to group by first column. And that's great. We have number of employees per department. So the thing you should watch here is that as your queries gets more complex, as you use more of those clauses, joins, groups, etc., when you write your query, the order matters, right? So the order to show you is always you start with select, then you have where, then you have joins, 1 or multiple join. I would advise you, to be honest, don't use the join, but be explicit. Use inner join or left join. exactly the type of join you're writing, because the type of join is important. At the really beginning, you should be fine with just join, but as you get more advanced, you need to know which type of join you're using, and it's better to be explicit. After this, after joins, you will have where. So remember, we wrote a lot of where clauses today, where salary is bigger, where name is this, where name is that. That will be after joins. And the group by is almost at the end. And if you know there, maybe no, maybe you don't, but there are other clauses, like there is something called having as well. That's gonna be at the very end. So all your SQL will be, the clauses have to follow the order. If you put the order wrong, you will have the error. And I can prove it to you, right? If you do this and you run it, syntax error near join, right? And to be honest, that's kind of cryptic error, right? You need to know that, okay, why there is back, right? The back is because the order is wrong. So let's put back the order, and let's leave it here. This is all. Final thoughts. If you attended the basic SQL session, and then if you also covered everything in this class, this will be already very powerful. If you practice it, if you master those things, this is already a lot of tools, and you can write really complex queries with those, right? The way I like to practice is, find a tool, find a database, something which will allow you to write the queries, and then ask yourself just basic analytical questions, right? How many employees within salary band? How many, which employee has the highest amount of projects? Which employee, has the projects which last the longest? Think about different analytical questions and then try to answer those with the SQL. That's the best way for practicing SQL. If you mastered all this material and you want to learn more, I have a couple of recommendations for you. It's not gonna be the sources, websites, but it's gonna be the topics. So instead of giving you the exact source, there is YouTube, there are many materials, books, etc., events like this. But I want to give you a little bit of order, because there's many things in SQL, but not all are as important as the others. So the first thing, if you master everything so far, would be to dive into the more types of joins, right? Cross joins, left joins, right joins, full outer joins. There are reasons why there are so many types of joins, and it would be good to know this, right? So you avoid the problems like we had here, that I've joined table and I've lost rows, right? So that would be the first thing to really, really understand, being able to effectively join the tables and consciously join this, so you don't lose rows. The other thing would be subqueries. So what are subqueries? Is a bit of inception again. It's a query within a query. So you, within single query, you write another query. And for example, right now we were selecting from, and we had the table name. How it will work with the subqueries, you actually can do select from, and then the subquery. And your query will work out the output of the other query. Like kind of similar thing when we work today on the single row functions, where argument was output of the other function. Here would be you would be selecting from output of the other query. So subqueries, definitely another thing to look at after the joins. The next thing I would look is a common tables expressions, if it exists for your database. If you learn Postgres, for example, if you work on Postgres, there are common tables expressions. This is a similar concept to subqueries, but as your queries gets more and more complicated, it's gonna be useful for you to organize and to write performant queries. Another thing is more single row functions. I showed you today just concat and I showed you length, but there's tons of those. Like depending on your database, there are gonna be different functions. It would be nice to familiarize with the documentation of your SQL dialect to find out more functions. They are useful, really useful single row functions. The next thing I would go after is the complex data types like dates, arrays, maps. So far, we work on the numbers and strings, but depending on the database, there may be actually pretty complex data structures like maps or arrays, which allows you to store more information in different ways. It may be really useful for some use cases, but definitely not for the basic. The last thing I would look at is window functions. So this is every time I mean, most of the time I work with people who know SQL, they will tell you that window functions are confusing or complicated. And that's why I kept it at the end. Those are really useful. To give you a quick sneak peek, the window functions allow you to access within single row other rows as well. May be useful when you're you're calculating things like running average or things like this. But you can do many things without Windows functions. So if you know everything pretty much up till this point, chances are you're gonna survive your career without Windows functions or with just a basic knowledge of Windows functions. So keep them at the end and don't feel worse if you don't know Windows functions. That's completely fine. There is reason why it's at the end. And that's pretty much it. Thank you very much. I hope you enjoyed the session. And yeah, thank you very much for being here. And it was an honor to present in front of you. Thank you.